we'll go talking about the recording in progress again. So I think we're good. Basically, cloud computing, I'm sure maybe Shego must have covered some parts of this, but repetition creates mastery. So forgive me for going over some of the stuff that you may have heard before. So there are three major things that are very, very critical in cloud computing. Those are compute, networking, and storage. Computing is the provision of virtual machines on the cloud where you can run your workloads. Your workload is whatever you're doing with the virtual machine, processing data, whatever you're doing to it, and you need a machine to be able to help you do that, that is compute. And one of the things that cloud computing does is it provides you with compute resources. Traditionally, people would have this in their data centers or they would do this locally, but the challenges with that are really numerous because from, first of all, acquiring your equipment, to installing, to maybe even if something like maybe you want to increase capacity, you couldn't do that easily, but compute allows you to do that in that with the click of a button, almost you can provision compute resources quickly. And networking, the internet, like as it's even named, is basically connection of networks, interconnection of networks, right? So networking is one of the very key things that the knowledge is critical because of how information moves. And I'm sure I don't know if this is something that maybe that you are aware of yet. Azure calls them virtual networks. I think AWS calls them VPCs, but these are very critical because they allow you to isolate your resources. Take, for instance, you work for company A and you have resources that you want connected to each other, from storage to compute to databases. You want them in an environment where you don't want people to have anyhow access to them, so to speak, right? So that's very critical, networking. And then the third one, storage, because I mean, with anything you're going to do, whatever service or product that you're going to be selling online or whatever, you're going to need to store some form of data, from people's information to media, meaning pictures, images, pictures, videos, and the like. And also, there are also things like storage includes databases too as well. So these three key things, they are quite important for you as a cloud computing enthusiast. I know we probably will have to cover somewhere down the line. We'll probably have to cover something like cloud job roles in the cloud. That way, you'll be brought up to speed with all the options you have. Because I know that many people have different interests. So there are different job roles, but we'll be covering that, and then you can then know what job roles require what type of knowledge, right? So I'm going to move to this slide. So these key things here that I wrote, they are part of the things that, since we're focusing on Azure, however, these things are kind of spread across all the cloud providers. There are things that are still important to other cloud providers too as well. Matter of fact, these are the things that they are offering. These are the cloud offerings. These are the things that it does for you. And it's very important because you need to be able to make this argument clearly. If you work for an organization, this is like your objectives to, in whatever role that you may be filling in. High availability. I have slides for each of them. So high availability, we have reliability, we have scalability, predictability, security, governance, and management, right? So each of our slides, we'll cover them now. So like I said earlier, in your traditional model where the company wants to provision resources, they first maybe write out a check to an equipment provider, and then the person ships down all those metal servers, and then they have to set it up. The margin for error is a lot. So you have your traditional versus cloud. This is what the cloud is offering you. In the traditional setup, the hardware belonged to you. You had to purchase it. You had to place it in physical locations. You have to secure those physical locations to make sure that they are secure. You also have to make sure, because these are servers that probably would run almost all the time, because you don't want downtime. So that means that you have to provide power, and also these machines will obviously bring heat, so they have to be in a cool place. And also, I think for someone like AWS now, I'm not so certain, but I think it is something, but you can go research it. One of the key things that they are promoting now is that you are also contributing to, what is that thing called? When you're consuming energy, like in massive amounts, whatever. But the idea is that they're helping you to also reduce, oh my God, I can't remember the name, but the idea is when you go with the cloud, you're reducing, I don't know if it's carbon, I don't want to say what I'm not sure about, but we'll move on. You have physical access and you can't just add servers. Say your server was to run out of space, or your user suddenly, say it's Black Friday and your user suddenly turned up to your website or to your app or whatever, and then what do? You can't just suddenly start to buy an equipment and install and configure and all that. So the traditional model has some downsides, which the cloud came to solve, right? Because with the cloud, which we'll see in a bit, we can just go on the Azure portal, create these resources, connect to them, configure them, and we're up and running, right? You can add servers in a click. If the hardware fails, you can replace them instantly. Unlike if you had them in a physical location. If this one fails, you can just go up and spin up another server. It's as easy as touch and go, right? And you can use clusters to ensure high availability. Now, the concept of high availability is such that there's this thing called SLAs, service level agreements, which you as a provider will give to your customers or to your clients to say that they usually say them in like 5 nines. I think they're from 5 nines. So you can guarantee that, okay, this service we're providing you, we can guarantee that 99.999 of the time to be up. So it's left for you to do your calculation and be sure that, okay, what 99.999 means is maybe out of 365 days, maybe that's 24 hours, maybe that's 10 hours, whatever. So you know what your solution can tolerate, right? I think, for instance, AWS storage has, I think, 5 levels of nines, which means quite durable, right? It's almost always available, like almost every time you barely hear it goes down, right? So we'll move to reliability. Reliability, also known as fault tolerance or disaster recovery, is defined here as the ability of a system to recover from failures and continue to function. And this is very important because with traditional servers, right, if you didn't set up systems to recover from any failures that may happen, when they happen, you then have to, when I spoke about SLAs just now, it means you now have, that's when you start to try to solve the problem. After the problem has already occurred, there is no fault tolerance. If there's a problem, what happens? There's concepts called recovery time objective and recovery point objectives. They are not in this slide, however, but what they mean is this: recovery time objective is the time it takes you from when your system has failed to when you're able to get it back up, right? And then recovery point objective is the point in your data. Say maybe you had data of 100, you have 100 data, and then from when your system failed to when you get it back up, there was 20 data that was added. But your recovery point is that 100. It means that you get back your data, but you're going to get that 100. So I hope it makes sense. Like I said, please feel free to jump in and ask questions at any time. Okay, so it says how you're able to ensure reliability is backups, right? Because here it says to deploy in multiple locations. This is also something that Azure is good with. It means that you can deploy your cloud infrastructure, your cloud solutions in multiple locations, wherever, closer to your audience and more than one. With databases, there's a concept called read and write replicas. The idea is such that you are not overloading any system too much, such that it's reliable. You can almost always say that if there's a failure, people will be able to either access maybe the last data that they got there, or that it is so minimal that it's something that you can handle. And it means that there's no single point of failure. Something that is encouraged more and more these days is software engineers, tech enthusiasts, anybody in tech. It's encouraged that you build loosely coupled systems. The idea of loosely coupled systems is that if one point fails, not everything fails. And going down that line, I think Shego will be the best to tell us about that. You have serverless, have Kubernetes, you have all the other cloud native infrastructure that you can bring in to make sure that you have reliable systems and that you have loosely coupled systems, such that if one component fails, not everything fails. And a good example would be microservices. Okay. So we go to scalability. Scalability, like the word says already, means your ability to be able to expand as resources, as load expands too, right? Automatically adjusting resources to meet demand. And an example of this is to increase the number of virtual machines to handle peak traffic. Now, you don't, there's so much that cloud computing can allow you to do, in that you don't have to manually attend to these things. Systems allow for you to set up auto scaling such that you can set thresholds that if these thresholds are reached, auto scale to allow this traffic. Instead of, for instance, when I said earlier that you had Black Friday coming on and suddenly your site is loaded with people and then the 500 server error, your site is down, but cloud computing allows you to be able to meet that demand by scaling your resources to meet demand. And what that also means is, like with traditional servers, you would have them up all the time, even when you are not using them. But scalability in cloud computing ensures that you're not going to overpay for resources, because when those resources are not in use, they're going to be down, and the list goes on. There are two types of scalability. There's horizontal and then there's vertical. This particular, this is something that you're going to be hearing a lot. So you might as well want to be able to differentiate between both of these things. Obviously, if you're going to be writing any of the cloud vendor exams anytime soon, it's something that you want to know the differences between. So there's horizontal scaling and then there's vertical scaling. When you are scaling horizontally, it means that you are adding more machines, like, and it's also called scaling out. You're adding more machines. So it's similar to saying I have a restaurant and I have 2 waiters, and then I want to scale out. I hire 2 more waiters, making 4 waiters, right? And then vertical scaling, which is also one of the ways, is increasing the CPU or RAM. So it's like saying I have 2 waiters, but it seems they're not really strong waiters. So instead, I have stronger waiters, right? So vertical and horizontal scaling, there you have it. Am I audible? Can anyone hear me?
Yes, we can hear you. I think
Oh,
I
okay.
was trying to mute other people,
Oh,
so
okay.
I
Oh, okay. Okay, so predictability. Remember that I'm going through this list. If anyone just joined recently, I'm going through this list. I talked about availability, reliability, scalability, and we're on to predictability at the moment, right? And this is being able to tell how your application will perform, regardless of the load or whatever that's going to come your way. You want to be able to predict, because when you're able to predict, it means a lot of things. Now, this is something that is quite silent, but it is always there, right? With any company, with any consulting, with anything that you're going to do, cost is going to be something that is going to be very key. And predictability goes towards cost, right? Because it means you may have a solution and the client wants to know, like, okay, what will this cost us? Both Azure, AWS, and GCP, they have calculators where you can arrive at a rough estimate of what this solution will cost you. Because cloud services, they will cost you money, but it's quite obvious what will cost you what. So it helps you to be able to say, okay, this is my solution, this is how it works, this is what it will cost me for for X amount of load or whatever, right? Say the application will always perform as expected, regardless of the customer load. So you don't have any surprises. Why I hammer on this point is because one of the key things that has discouraged companies so far from cloud adoption is they end up running into surprising costs at the end of the month, because most cloud vendors, your bill will come in at the end of the month, and it scares many would-be customers of cloud, so to speak, because they're not able to keep the cost down. Then they end up trying something else. Okay, and also what predictability does is a consistent experience for your customers. And that is very important because customer satisfaction is very critical to business growth, right? Auto scaling, load balancing, and high availability, they provide you a consistent experience. What this means is your customers can be sure that whatever service this is, whatever is going to be up or whenever. So track and forecast resources. And what this means is in real time, both Azure, GCP, and AWS, they have services that allow you to track and forecast resource usage. And why this is important is it helps you to know what services you are currently using, what services you are not currently using, and then you can then optimize. If you're not using it, then why do you have it going? Maybe you might want to, if it's a virtual machine and a bigger size than whatever what you're doing is, you might want to maybe adjust it so you're not paying for something that you're not using, right? So and then analytics. This is very, very important because for something like storage, for instance, there are services that allow you to be able to say maybe you were storing things in maybe say a bucket or whatever. It can detect the patterns with which you are using it and recommend ideal ways for you to be able to make better use of it, right? And then you can then make use of those recommendations. Security is very, very key because I know that from the last session that Shegun had with you guys, we talked about security already, and security is very, very important because it is broken into two forms, I guess: security off the cloud and security in the cloud. And it's your responsibility while you're dealing with cloud computing resources to ensure that you are interacting with them in a secure manner. You are not doing things that will jeopardize the security of your resources. That is your own responsibility. Security of the cloud is the responsibility of the cloud vendor. They would make sure that you get things such as the SLAs that I mentioned earlier of your uptime. They will tell you what guarantees you have for whatever service. and also recommend how you should behave towards. For instance, I'm sure maybe some of you might have read about multi-factor authentication. It's something that is highly recommended, especially for root accounts. That's just one of the ways that you can ensure that you are being secure while using cloud resources. Okay, and then governance. Also, I remember Shegun talking about something like this in the last session, and I think it was from a question someone had asked him about data regulations, or maybe a particular government of a country having issues with data of their citizens being moved in certain ways. And he did mention rightly that there are services and the services that can help with this kind of thing, where you are applying a hybrid cloud approach towards whatever you're doing, right? And depending on what type of data you are handling, different governments have regulations, and it's important that you know this as the cloud engineer, cloud architect, data engineer, whatever. It is important that you know what you can and cannot do as regarding the law, because this is very, very important. What cloud computing does is it gives you standardized environments, it gives you regulatory requirements, and it gives you audits to make sure. And all these things that I have mentioned, they have services for you to be able to detect, to say, okay, am I being compliant in this type of way, in that type of way? And there are bodies that will most likely regulate the company that you're with. They will audit to make sure that these things are so, because there are licenses that those companies have been given, which they have to abide by. Take, for instance, if you're handling, say, credit card information, you're handling PII, which is personally identifiable information, say maybe health records. I know that the United States, for instance, has the HIPAA, Health Insurance Portability Act, something like that, which does not allow the health records of US citizens to be housed outside of anywhere that is not the US. So these are all things that you want to make sure that you're abiding by. So it is also something that the Azure Cloud will provide you. And then we're going to go to manageability. Manageability, I think most of the headings of the things I've been talking about, they're quite descriptive. So it's not too vague for us not to understand. Manageability is trying to talk about how easy it is for you to be able to manage all these things that you're doing, right? With management of the cloud, meaning management of resources in the cloud, I already spoke about how things like auto scaling allows us to be able to manage customer traffic and whatnot. Monitoring, to be able to know when our resources are up, when our bill is going up, and stuff like that. Also, Azure provides lots of templates, so you don't have to build from scratch. And also, in terms of manageability, there are many managed services that Azure provides. And most cloud vendors will encourage you to use managed services because it frees up your own resources. What that means is your developers or your engineering team, they can now focus on building features, which is what the core strength of your product or what you're offering is, instead of having to deal with, okay, how do you do this? You can use managed services, and in that way, you don't have to bother about patches, bother about many of the stuff that you would normally worry about, right? Management in the cloud is referring to the fact that, like I said earlier, we are able to use a portal. We have a dashboard where we can spin up all these resources and play around with them and do whatever and whatnot, right? And then the command line interface. For those of you who are pretty new to tech, you might not be so familiar with the CLI yet. However, it's something you should know about. There are several ways that you can interact with cloud resources. other than the portal or the dashboard where you're able to spin up these virtual machines or networking resources or storage resources, you can also spin them up on the command line. And a good example of the command line is bash. Let's see. Any questions so far? Can we see my bash? Can we see this? Can you see the bash prompt on my screen?
We are only seeing your PowerPoint that you shared. Maybe you should,
Oh,
when you share your screen, you should share online.
okay, well, it's not such a big deal. You can always find out about CLI. It's not such a big deal. However, what it means is, it means that from my command line, I can give commands to my cloud resources. Obviously, there's a way that you have to link both of them for you to now be able to give those commands. But it means that if I can go to the dashboard and spin up resources, I can also do it through my CLI and give those commands and everything. And then application programming interface. Azure provides several ways for you to be able to create and manage APIs. APIs are like the lifeblood of any product or application because they create a way for the users to be able to send commands, so to speak, or to perform actions. The most common actions that we know are CRUD, which is create, read, update, and delete. And if you look at it, those are like some of the very key things that we do on any product. If you think about it, you're either creating a resource, you are reading the resource, you are updating it, or you're deleting it, right? So, and you are able to do these things through API. Okay, then, the economics of cloud. So now there's something called total cost of ownership, right? And it is very important because when I spoke about your company or wherever or whoever buying those virtual machines physically by themselves, the cost of them going out to do all that, it begins to add up, right? So now, one of the things that it does for you, one of the things that cloud does for you is that your capital expenditure, it reduces it. Ordinarily, you'll be spending a lot like on acquiring and maintaining those fixed assets because those equipment, you have to buy them at once. You're spending that amount of money. Take, for instance, there are different categories of virtual machines on Azure, depending on the size, CPU, the RAM, and whatever it can do, right? But we don't need to buy it all at once. I mean, we can just as we need it, right? It means that our capital expenditure is much reduced, and it just gives us much more leverage, right? Something else it does is it makes our operational expenditure really minimal, right? Because we are paying for those resources as we use them, right? And for many of the cloud vendors, there are savings plans where you are able to either purchase resources in one go and they are much cheaper. So you end up arriving at a total cost of ownership that is way below what you would have spent if you were trying to get those resources, get those resources physically, right? Okay, so I'm also certain that this is something that you may have covered, so I'm going to really run through it. Cloud service models, right? You're going to hear about them a lot. That they're everywhere because you are going to either be dealing with one of them or a combination of one or more of them, right? IaaS, PaaS, and SaaS. Sorry, I didn't put this. That's infrastructure as a service, platform as a service, and software as a service. When I spoke about virtual machines earlier, I'm referring to infrastructure as a service because that's infrastructure. When I was talking about those resources that you can use for storage, for databases, for networking, that's infrastructure. right? And running through some of them, okay, you can see some examples here already. There's virtual machines, virtual networks, storage, all these are infrastructure that you can provision, right? So depends on what you're dealing with. You might be maybe say working with infrastructure as a service or provisioning infrastructure. And some of the differences in these cloud service models and why they're important. With infrastructure as a service, for instance, you have complete control because you are the one who decides, okay, I want to provision storage. I want to provision this virtual machine, right? And they're dynamic and flexible. You can do almost anything, because you're really free. You are not limited. If you have one virtual machine, you want two, you want three, you want four, depends on you. And your cost varies. It's your consumption that determines that. And you can do as you like, right? Because you own the infrastructure. Even you can allow multiple users to use a single piece of hardware. One particular machine, I remember one of my former colleagues used to say that how he learned to work with virtual machines a lot was because the company he was at provisioned virtual machines for the employees. Obviously, the same virtual machines, and then gave all of them access to just play around with it as they like, right? Because they own that infrastructure, right? Platforms. When I spoke about managed services earlier, am I too fast, please? I've noticed nobody has asked any questions. Is it that they're understanding or they're not understanding? Let me be sure. Once again, I'm going to accept silence as consent.
We are understanding.
All right. All right then. Platform as a service. All right then. That's awesome. When I spoke about managed services earlier and how they are much more encouraged because they allow you to do much more stuff, like the focus of what your business is, right? A couple of those, Azure has what we call app services, and it is something I need to. One second. There's something I would have liked to show us, but okay, when I go into demo mode, when I'm trying to show you guys stuff around, I'll show you that app services, right? But app services is something that allows us to use services without, how we're supposed to provision the virtual network by ourselves, virtual machines. We can just come and Azure has this marketplace, which is actually what the next thing that we're about to talk about, where you can pick several services, and then app service just helps provision everything. You just do the least minimum, and then these things are going. Like I said, they're managed services. So we'll talk about some of the characteristics. Resources are virtualized and can easily be scaled up or down. All right. Services often assist with development, testing, and deployment. Right. Multi-user access, integrates web services. The key thing about platform as a service is, like I said, app service just helps you to do something. It has created a platform for you, so to speak, to just come, do that thing and go. Unlike the infrastructure, where you're the one who provided the infrastructure, platform, and then the service that platform is going to run, right? And then software as a service, which is like the most familiar one that we know. I'm sure most of us have applications on our phones, on our computers that we use to do stuff. Some of them paid, but there you go, they are software as a service. An example is Microsoft 365. It can be managed from a central location, they are hosted on a remote server, and they're accessible over the internet. And the users are not responsible for hardware or software updates, right? And then rate limiting. Oh, okay, this is quite technical. Rate limiting and QoS. QoS means quality of service. Rate limiting has to do with APIs actually. I wouldn't want to go there. I wouldn't want to go there. I don't want to take consultative for There's really no need for that, but it has to do with APIs and how you want to control how often they are called and stuff like that. So that's the cloud service models there. Very important. Infrastructure as a service, platform as a service, software as a service. And these are some examples of these cloud service models. Okay, so now we'll talk about the Azure Marketplace and what we're able to do with that. It's like how you have Google Play Store or App Store. Oh wait, am I missing something? It's called App Store for iOS. Whatever it's called, but it's a marketplace where there are many services where you can just come and then use and go, right? So there are solutions and services, the large selection from Microsoft and its partners. So as you can see, there are apps, there are VMs, there are templates, there are services. Apps will help you do maybe a particular thing, virtual machines, templates. Templates may be a particular way of doing something where you don't have to build it from scratch by yourself. It's already being done by someone else or by another vendor, and then you just come and you use it. And then the Azure App Store, you can buy cloud services with a single click. Yes, integrate. So how you can get started using them it's pretty simple. You can use from the portal, like I told us earlier, CLI. Some are free, some are paid. Yep, and there we go. So I'm going to leave the room open for questions before we go into like more of the demo stuff. If you have any questions, now is a good time to ask them before we go into the other demo stuff.
Hello.
Anyone? Yes, I'm with you.
Okay, yeah, I have a question.
All right.
We have three different service model, like infrastructure, like one you shown us here. Why does someone not go for the simplest and the easiest? Why do we now need to have? I'm thinking the infrastructure as a service is more complex than the maybe platform. Or so, what is the criteria for going for which of these?
Okay. Okay. Well, that's a good question. Now, one of the main challenges that many companies have with cloud computing and whatnot, and also this goes to say why they get paid very handsomely, is the availability of talent that can actually do these things, right? So one of the reasons why you would be encouraged to use managed services, maybe because of skill, like the engineers at the company, what are they used to? What do they know? You don't want to just have them jumping into something and making a mess out of it. For instance, maybe if they don't know how to use it, they may end up coming up with very, very large sums of bills for the company at the end of the month because they are not familiar with using it. So with many things in the cloud, right, the answer you're going to get is it depends. The answer is going to be it depends, right? So there might be scenarios where you want to provision your own infrastructure because it gives you the flexibility, like I spoke about earlier, that allows you to be able to do like really, really cool stuff. Like you can do as you like because you are the one in charge of everything of that infrastructure. You can play around with it. You can, I don't know, whatever you would like to do, right? But when you're using managed services, they're quite like they're quite easy to get going. Like you're not going to spend a lot of time. So yes, it depends on what you're trying to do, right? It depends on what you're trying to do. If you're trying to say maybe the solution that you're working on is not some, maybe you want to make tweaks to it. You want to customize it in a certain way. You might want to maybe have that flexibility. For managed services, but how you plug in may not be something that it's so flexible for you to be able to do. Maybe it kind of restricts you. So you want to build your own infrastructure by yourself, and also because you have the knowledge to be able to do it. So yes, one may be easier, but it depends. Because also, like managed services are paid services. They are not free. Not like infrastructure is free too as well. I mean, but you know that they've abstracted some stuff for you. They've done some heavy lifting, so they're asking you for money in return. sort of. I hope that answers your question.
Yes, it does.
Okay. I'm trying to get the login for this. For this Azure portal. Any other questions? Open to entertain other questions while I get this portal ready. Okay, almost there. Any other questions about this slide or any questions in general? Okay.
Okay, sorry, I just thought of one now.
Okay,
Uh,
go.
yeah, so I think this question has been asked before in some of our previous classes, but I want to ask in another way.
Okay.
Is having a knowledge of cloud without coding, just having a knowledge of
Okay.
how everything, is it sufficient enough, to land a job? Say, I know how to play around with this console, or I know my command line very well. I don't need to know any language, so to speak. Is it sufficient to land the job?
Well, my answer to that would be I don't want to be. My answer to that would be also it depends. One of the things I was even yes, I think I should present now. One of the things I was thinking about before giving this slide today was I thought about the audience, and I thought that one very important thing that may be on the minds of some of you, and which is also very would be that okay, I want to be able to decide what part of cloud. Can we also my screen? I want to be able to decide
Yes.
what part of cloud I go into, right? And remember at the beginning of this session, I mentioned that what I would like to talk about is job roles in the cloud. I can quickly go. Yeah, I think I have a tab on that. If this thing will leave my view. Please resume. How do I get this out? Oh, okay, yes, there we go. There we go. There we go. Okay, so now the question is, I know why I'm going this back, right? Some of the things, why I answer them the way I answer them is when I got into the cloud, I mean, I had these questions too, right? And it took me a while to figure them. So, and I know that me knowing them earlier on would have been able to direct where I have my focus more, right? And I know that that's where that question is coming from. For instance, okay, I want to be in cloud computing, but I don't want to write code. I mean, is there space for me? Yes, there's space for you. But the thing is this, right? Cloud computing kind of overlaps in certain areas, depending on the roles that you want to hold, right? So there are a couple of them. I'm really going to go fast over them. So I'm sure some of them you might have heard of them before. So now, for instance, there's a cloud architect, which is what, for instance, someone like me, this is what me I'm interested in doing, right? A cloud architect, you're responsible for high-level design of software systems. So what it means is that you're going to be deciding what are the requirements, what infrastructure is needed, how does it communicate with the other infrastructure? Okay, what is the proof of concept? The proof of concept is after you have that architecture working, how you build it out in a very small way, right? And then you're able to demo it and say like, okay, this is how it works. This system talks to this system, and this system brings it here, right? So, for instance, as a cloud architect, I write code, but it's not like a high-level prerequisite for you to write code. As a cloud architect, you could design, for instance, the architecture and get an engineer to build out the proof of concept for you. I mean, it is a plus Don't get me wrong. Any day, anytime, it is a plus if you can do that on your own, right? Because it sort of gives you, in conversations, it sort of makes you, it gives you much more information to be able to decide quickly to say, okay, this will work this way, this will work that way, right? So maybe don't be a master at it, but know what the details, the little details around it are, right? Yeah, I have friends who are, I have a friend who is a data engineer now. Like she works with GCP. She's not like a code person, but at least she knows enough to do what she needs to do. So don't be scared by it that, oh, I need to write code, I need to do this. There are many roles. For instance, a cloud architect, you are designing infrastructure and how they communicate with each other, and then presenting it and saying, okay, this is what it will cost, this is how it should be set up, this is why we're using this one, this is why we're using that one. Also, there's site reliability engineer. Site reliability engineers, they ensure that these systems stay up, right? So what they do most of the time is they use tools. They use tools that help them to monitor maybe things like network, traffic, and those kind of things. So that way they're able to make sure that those sites stay up almost all the time. For instance, you may know of sites like maybe Amazon, or maybe an e-commerce stores that you know, and that they're always up. Obviously, they have site reliability engineers, and those guys use tools to make sure that they're gathering information. Okay, yeah, here we go. Says the SRE spends their time gathering data about the systems they operate through telemetry, right? So it means that it suits those who like data and investigations, because when any system is up, it is generating information, it is generating data. So these site reliability engineers, they go there, they understand what that data is, and then they're able to say, okay, no, let me avert what may happen if I continue to leave this, because they have a tool that they're using and they have processes, and then is able to help, right? And then software engineer, obviously this person writes code. And there are different types of software engineers, right? There's a front end, there's back end, there's full stack data engineer, keeps going, right? And obviously, back end engineers, as we know them, they're the ones who write these APIs. When I talked about APIs earlier, APIs are like, there's this famous example that people use all the time. They refer to APIs as waiters in a restaurant where they take your order, right? So the software engineer, obviously, this person writes code, right? The cloud engineer, this person manages, maintains cloud accounts, and also even advises on what the best practices are, right? In terms of security, in terms of infrastructure, what they do, they're required to write code. But most of the time, many cloud providers have a way to write infrastructure as code. Remember we talked about infrastructure as code earlier, right? Now, it can also be written as code using things like Terraform, I think, infrastructure as code. So obviously, but this infrastructure as code, these tools are not, I don't want to scare you. They are not, I don't want to say they are not difficult. But they are quite easy to understand. Like nothing is difficult if you put your time to it. That's what I think it is. So obviously, cloud engineer, you are going to be writing code. DevOps is actually development operations engineer, and the roles kind of overlap. That's what this person is doing, kind of overlaps with the site reliability engineer. However, it is not, because the DevOps engineer focuses more on building the continuous integration and continuous deployment pipelines, right? This is something that you're going to hear a lot. Continuous integration means after your product has been launched, has been posted, it is there. So now let's say users want a new feature. So maybe you want to implement a dark theme, or what they call that thing, a dark theme for them, and all the users are really, really clamoring for it. You want to be able to make those changes in an ongoing way without breaking anything, without spoiling the system, as it were, right? So these DevOps engineers, they ensure that you are able to keep making changes in a very, very quick manner, right? And then continuous deployment, meaning that as your code is being pushed to the cloud, right? It is being built, and it is being tested and everything is good. So it's not they're not going to say, okay, after you deployed that dark theme that we're talking about, the whole site just went down. Like nobody could do anything again or stuff like that. The DevOps engineer exists for something like that. Yeah, okay, so here you even see how much coding. Maybe I should share this link with you guys. It's much like a cloud engineer or site reliability engineer. The DevOps engineer won't write much application code, right? So it means this person is not writing much application code because they are much more worried about how to build pipelines to make sure that these things are like they stay up, right? And then I think there's still one more. Yeah, the data engineer, right? Okay, so a data engineer is responsible for handling the company's data and putting it to strategic use, right? Lots of companies generate data that they don't have insight on what it does, and there's this concept called business intelligence tools. Yeah, business intelligence tools, and these data engineers know how to use it. And not just that they know how to use it, they are also in the business of breaking that information down to like the layman, well, not the layman, the board, for instance, so that they can make strategic business decisions. Because the data engineer can come back and say something like, I found out that your store sells the most on Tuesday evenings by 4 p.m. At least that's good information because now you can stock up against Tuesday evenings by 4 p.m., right? So let's see how much code they write. Data engineers certainly write code because they need to interact. And the reason is because they need to interact with systems, right? Because data is moving from one place to the other. So obviously, you have to intercept them at a certain place and understand what they are doing, right? And then quality assurance engineer. They're responsible for ensuring that newly created versions of software work as expected. Most of the time, they're usually dealing with testing. Like they need to verify that things work in the way that they work. And there's automation software too that they also need to be familiar with using. That will help them do their work. Sometimes they do these things manually, but also there's also automation software that helps them to verify what is working. Not much code, like you see here, low. Q engineers, they work on automation and write a lot of code, but there are also roles that have very limited understanding of software and programming, right? Yes, and also cloud support engineer. They resolve customer queries. Another thing, I think another name for it, cloud support engineer. There's another name for them. I can't remember, but cloud support engineer or cloud support roles, most of the time they are customer-facing roles. So say maybe it may even involve things like maybe solving customer tickets. Maybe customers have a problem, they provide you with the problem, and then you have to troubleshoot and tell them, okay, what are you doing right? What are you not doing right? And then resolving those issues, right? It depends on this cloud support engineer roles, right? Most organizations, you find out that there's cloud support level 1, cloud support level 2, and stuff like that. So it depends on how technical they have you working. So the technical skills you require may be high, maybe low, and you're not writing code. You're not writing code. Very little or often no coding is required. However, you do need to understand the product very well and the areas that customers can have problems. That way, you'll be able to solve some of these problems, right? So I hope that I was able to answer your question. I'm not sure who asked that question anymore, but I hope I was able to answer that question about how you need to write code.
Yes.
Or if you need to write code. Okay. Okay. So now, what you're looking at, you can still see my screen, I believe.
Yes, we can.
Okay.
Oh, I can.
Okay. What you're looking at right now is the Azure dashboard. This is what the Azure dashboard looks like, right? And while we have spent our time I'm not going to expect you to know everything that I'm going to talk about here at once, right? So some of the things, it will take you a while. Like I said, repetition brings mastery. So some of these things, you see them and see them and see them again, and then after a while, it starts to become much more familiar with them, right? So when I talked about Azure Marketplace, so let's go check that out. And Azure Marketplace is a place where we see, you notice I'm using the search. I'm not doing anything fancy. I clicked the wrong one. This is what I wanted. Marketplace. There you go. So, okay, some of these things will be foreign to you. I mean, some of them are foreign to me too. But you can see that some of them have prices on them, right? And they're for different things, right? So I'm going to go into one that may not be too technical and such. But you see some of them, they have prices on them. Some of them have prices on them, some don't. Trying to show now. Okay, so let's look at this one now. Azure Lighthouse managed backups. So this offer enables CoStone to manage your Azure backups on your behalf. Let's click it as if we want to have a look at it. And you can read through it and then see what they are offering and see the people who provide it. As you see this is provided by CoStone Solutions Limited, and you can add them to favorites, and you can do like all sorts of other cool stuff with them. I don't want us to spend too much time here, so let's go back. But I want to believe that you have an idea. Look at the price. This is what I meant by the prices. You see that for this now, SFTP is simple file transfer protocol. Yeah. So that's like for moving files around, right? On a Linux server backed by Azure, blob storage. So storage, file sharing, and much more. An hour, you're going to spend 0.029 cents per hour. I hope this kind of gives you sort of an idea what the marketplace is doing, right, with these cloud vendors. But this does not mean that you can't go and like get your own thing going. Like we're still going to go into like the other services and have a look at that, right? So that's like marketplace for you, right? I'm going to go back home and go to the dashboard. Dashboard already. Services. Some of the common services we talked about. There was something I said I'll tell you guys earlier, but I think I forgot. Virtual networks. Let's talk about virtual networks first. Networks are really, really important because when you're having resources in the cloud, you want to have them. You either want to isolate them in their own and have them talking to each other. So obviously, you're going to need to create virtual networks to have that going, right? Okay. Subscription is okay. Well, what I didn't mention earlier was that networking involves IP addresses. I'm sure you guys are familiar with the word IP addresses because any device that is connected on the internet has IP addresses. And currently, what we're using is IPv4 addresses. There are also IPv6 addresses and IPv4 addresses, right? Like, sadly, I'll not be able to create one because my subscription is I'll have to use another account to be able to do that, but that's content for another session. I just wanted you guys to have like to see what really happening here, right? I think maybe what I should show us also is what's storage. Storage. storage account. Will I be able to do anything on it? Well, like you said, disabled. Well, this is content for another time. I would like to like really settle down and like go through this. But what I should do is let me show us virtual machines last. And see. Oh, I won't be able to create this. Okay, yes, I can. This is me trying to spin up a virtual machine. Oh no, I can't. Well, this content for another session. I'm very certain about that, so I'm not going to even sweat it. But in the next session, where like we'll be much more hands-on, and like I'll be able to go over like concepts in much more detail. We'll be able to go over this. But what's supposed to happen here is I'm supposed to fill up some of these empty boxes and spin up the server, and then we have it going. You see here it says review and create. What's supposed to happen is I generated this result, this virtual machine, and spin it up, and it's going, and then I can connect into it and make it a server, and it's up on the internet already. But this is, like I said, this is content for another time. So what I'm going to do is I'm going to stop here, like, because this is getting quite technical, and I don't want to lose us. So I would like to take off from the beginning of something like this. So, what I'm going to do is I'm going to take questions instead, if we have any questions so far. And the word I was looking for earlier was carbon footprint. Somebody actually said it. I didn't say that. Carbon footprint. Any questions?
Okay.
Am I in an echo chamber?
Yeah. I'm not seeing any question in the chat, so
Okay.
probably we take silence as
Consent.
no. So yeah,
right.
thank you, Samson, for the section today, and really appreciate your time. So
Thank you
to
very much for having
everybody,
me.
yeah, you're welcome. So to everybody, we're going to continue tomorrow, and I believe tomorrow will be more hands-on, in which we are going to see how does the platform looks more. We look at how some resources and how apps actually look. So like I said in all my previous classes, this just looks like an introduction. Just want to expose us to what is cloud computing, how does the cloud platform looks. So if you are a bit confused or you don't get it, you don't need to worry or bother about it. So in our subsequent class, you get to understand it more as we organize subsequent sections and different trainings. So just feel free and enjoy the introduction. So that's what I would say. And again, when it comes to coding, I mentioned it earlier that coding is not just about open your system and typing let I equals to so for I in I do this. No. Coding is about how you feel. Coding is about your it's more like your problem solving ability. It's not that you are just going to get there and just writing Python for you to write a code that will on and switch off street light. No, we are not doing that. But it's just more like helping you in when it comes to problem solving. Even as an architect, you need to understand the application that are being run in what you are designing. So more like you understanding if you want to create a architect a cloud, or you want to help in migration of people to the cloud, you have to understand what is their product, what are the tools that is running on, what are the application, and this is not might not be just open Python script and running script or writing script code like that, but you have to have the understanding of what is there, and for you to have the understanding of coding, you must be involved in it. So that is just it. So I know people are like, many people don't want to buy into the idea of programming or coding, and they want to move into IT. It will be kind of difficult in some way or the other. Many people that don't code, if you give them a code, they will read it for you, they will interpret everything for you. And why? The fact that they don't code doesn't mean they don't understand everything that is there. And how do you understand? You understand with hands-on. That means you have been doing it. So that's what I just want to keep him into that. And I don't know if anybody still have any question, but now I think I will stop the recording.